Welcome in. It's time to go through the video assignments for chapters 2 and 3 and then also chapter 4. We'll do it in one video because the data sets are actually the same between the two. So we'll just answer a lot of questions in this video. All right, exercise 1. It says make a fictitious data set that contains 10 observations of a variable. With this data, create a 5-number summary and sketch the corresponding box plot. And as I was helping with some students in Just Ask, they were doing this by hand. I'm like, oh, that's great, but we're not going to do hardly any statistics by hand. So if you know how to do it by hand, by all means, go for it. I'll explain how to do it by hand as we go through this. However, I do want to make sure that you're able to do it with Excel. Okay, so we need to go into Excel. I have my data set here. I just made some random numbers, or rather I had Excel generate some for me. And so now to the 5-number summary, typically when you see a box plot, you have the min, you have a max, and then you have the median. Okay, maybe I'll list them in order. So the median would go in the middle, and then there's the max, and then there's this Q1 known as the 25th percentile or the first quartile, and then there's Q3, which is the third quartile or the 75th percentile. Okay, so to find the minimum, this is a small data set, so you could do it by hand. You can see it's 4, but let's just confirm it with Excel. We're going to do equals min, and then open a parenthesis. If you want to get that command entered quickly, just hit tab. And so then highlight the data set, close it, hit enter. Okay, I'll worry about the Q1 and Q3 in a minute. Median is surprise equals median. Hit tab over to insert that. And then again, this syntax means give it an array of numbers. So select the first one, and if you want to select the entire column of data, you can, on a PC, hold Control, hold Shift, press down to select the entire column of data. Okay, on a Mac it would be Command Shift down. Okay, close it. Hit enter, 19. And again, median, you know how to do it by hand. You arrange them all in order, cross off the ends until you get to the middle, right? Maximum equals max. Okay, highlight data set, enter. Great. Q1. Now there are a few different commands that you can use for Q1 and Q3. There's, truly is called the 25th percentile. So if we type in percentile, there's EXC and INC. Okay. Now, which one do you use? That's a very good question, and this is one of the sticking points among statisticians. Statisticians are very problematic people. They argue about a lot of things. This being one of them, and there's no good reason to pick one over the other. It's just a convention that you want to use. The suffixes stand for exclude, EXE, or include, INC, and that would be including or excluding kind of boundary values. So it's a philosophy thing. Are you glass half full? Are you glass half empty? You pick based on the day. But I will tell you, for achieve is always going to want you to use EXC. Okay? EXC, always for achieve. And actually, that's how Excel generally operates as well. I'm going to tell you more commonly, statisticians use INC. So we're going to default to INC for anything you submit to me, Excel labs, exams, etc. EXC is for achieve. Okay, I'll repeat that one more time. EXC, achieve. INC, anything you submit to me, submit to Canvas. All right, so we're going to use INC, and then select our data. When it says array, we select our data, and then the K value is the percentile expressed as a decimal. So if we want 25th percentile, we do 0.25. Okay, enter. Yahoo, we got it. The other command that you can use, it is the first quartile, so you can use quartile, and then EXC and INC operate the same way. INC, select the array, select the data, and then quartile, here it actually pops up, and we want, the first quartile. Okay, so select that one, double click, enter. Same thing. Okay. Third quartile, we can use quartile.inc for the first go around, and we'll confirm it with percentile in a moment. And then we do 3 for third quartile. Same thing here, we'll use percentile and select our array. and then 0.75 for the 75th percentile. Okay, there you go. Boom, we got it. So now, do we make a box plot of this? No. Okay, if you wanted to do this by hand, you'd have to use these numbers. To make a box plot, you actually want to select the original data, and Excel will do all the calculations for you in the background. Insert, box plot is under the histogram option. There you go. And my screen is zoomed in a little bit, so I'm just going to zoom out a little bit. Okay, so here we see min and max quite clearly, right? Median, and then again, if you hover, this X is actually your average. So we didn't ask it to calculate the average, but or we weren't asked to, but we could. And then you can see the median, or the Q1 and Q1 would be down here at 10, and then Q3. Now this one again, it uses EXC, so it's showing in Q3 of like 29 when our version that we calculated with INC is 25. And then of course we can make it pretty, so add axis titles. Now truthfully, when we do a box plot, it is a univariate one variable visualization, so we actually don't have anything along this one axis. Okay, but the vertical axis here, this would just be like value or whatever the variable is that we're looking at. So then I would just say that this is the box plot of values, okay? And that would be my completed histogram, or box plot, okay? Or box and whisker plot, all right? So again, for me, percentile, quartile.inc, for Excel, or for Achieve, percentile.exe. Okay, that's question one. Question two, every extreme value is an outlier. Well, okay, so no, mathematicians and statisticians were very sensitive on language as we're learning, right? And so is this true? Well, no, it's a possible outlier, but actually remember that there is a process to figure out if something is an outlier. That's the 1.5 times IQR rule. Actually, that's the process we're going to use in this course. So that being, there are multiple processes to figure out an outlier. The one that we are using is the 1.5 IQR, but regardless, we can't classify something as an outlier without going through that process. So to say every extreme value isn't automatically an outlier is not true. Okay, so I'm not going to write that out, but you got the idea. Okay, exercise 3. Okay, copy the data set, make a scatter plot. Describe the cloud of points. 3 descriptors. And then determine the value of R and the type of association. Alrighty, so I do have it all copied in Excel. Here we are. I'll zoom in just a pinch. So I'm going to make a scatter plot, highlight the data, and do insert scatter. Okay. And when we do a scatter plot, the column on the left is automatically, by default, put on the horizontal axis. So you might need to, in certain situations, depending on how your data is presented, switch the columns. Hint, hint, wink, wink, nudge, nudge. So that's something to look forward to in the activities. This would be variable 1 values. And then vertical axis would be variable 2 values. Okay, and then we can just do scatter plot of variable 2. It's always y versus x, so variable 2 versus variable 1. Okay, or you can just say scatter plot of the two of variables blah and blah. Okay, you can just say, actually that might be better. So let's do of variables, variable 1 and variable 2. Okay, just that versus language is always a little contentious if it's y versus x, x versus y. Okay, there we go. So that's our scatter plot. Okay, I already forgot the other instructions. Sketch scatter plot. So okay, copy paste. Describe the cloud of points. Okay, and then determine value of R. All right, so describe the cloud of points. So I need to mention direction, form, and strength. Okay, and this is based on visual inspection only right now. So direction, it seems to be going up and to the right. Okay. Form, generally we're going to default to linear. If I wanted to be more descriptive here, I could say, it makes kind of a wedge or a fan type shape as it goes to the right. That could work too. I'm not going to be super sensitive to the form. Generally in this course, we're always going to do a linear form. And then strength, I mean, as things go to the right, it kind of disperses more. So I'm going to say maybe a weak strength, or maybe, so moderate would be they're kind of bound tightly together. So maybe this is moderate. So I could say weak or moderate, but definitely not strong. Strong would be like it's almost a perfect line. And I don't see that pattern going on here. So I'm going to go with up and to the right, linear, weak. Okay, and so now we can calculate R, right? So two different ways. We can go into data, data analysis, and then in the pop-up window, we can select correlation, input range, select the the data for the two variables, output range, put it somewhere around there, sure. And then my correlation is the non-1 number, so it's the 0.5 number. So actually this is well, actually that's pretty moderate. It's a moderate correlation, moderate strength. Okay, you can also get this number by doing equals correl, and then select the first variable, comma, second variable. There you go. Get the same number. Okay, so that's our R value. R equals. Okay, and so I would say this R, it's positive and it's moderate, and then based on the graph, we would say it's linear, but at least from R, we can get positive, moderate. Okay, and that's the end to this exercise. Okay, type of association is positive, moderate association. All right, that's Chapter 2 video assignment. Looking at Chapter 4 now. We have the same data set. So scatterplot LSR line. Okay, we need to make this the LSR line. Now, Excel doesn't have, as some of you pointed out in the discussions, it doesn't have LSR as an option, but it does have trend line, and all the method that Excel uses to calculate this trend line is least squares regression LSR. So then we just have to make sure that when we do this, we select linear. And even if you wanted to, remember that go into more options, or you can double click on the trend line and the side panel will open, and then select display equation and display R squared. Okay, so I get the equation and R squared. I'll zoom in just a smidge more. So there we go. R squared is about 0.25. And so then what else was shown? Let's see. So sketch, write the equation of the LSR line. Okay, we got that. So the equation is the y equals x minus 0.1429. All right, moving on to part B. Determine the value of R squared. Okay, that was the 0.25. Determine the type of correlation. So the unfortunate thing about R squared is it only tells us strength. It doesn't tell us direction and form. So generally R squared, in this course we're always going to use linear, but at least here, R squared, since it's between 0.1 and 0.5, that tells us it's moderate, so that matches with what we just talked about. And then that's all we can say. So that's all we can say is it's a moderate correlation. And that's all the further we can go with that one. Okay. Oh, actually, I'll save that comment for number 3. Exercise 2, interpolation and extrapolation. Okay. As we look at a scatter plot, interpolation is predicting between the bounds of the data that we already have. Okay. So if we were to be asked about a value of y when x is 2.5, we can totally do that because we have a prediction for that. Extrapolation is what forecasters do in meteorology, and it drives me bonkers because they're always wrong, right? Well, or seemingly always wrong. But they have advanced statistics that allows them to do that within a degree of accuracy. Nevertheless, at this level, we don't have those tools, and that's why we always caution against extrapolation, which is predicting beyond the range of the explanatory variable. So if we were wanting to predict for, what is y when x is 0.5, right? yeah, we could do it. We could put in 0.5 for x and see what we get, but it's beyond the range of the explanatory variable. So don't do that. That's not okay. All right. Um, Again, you can do it. Your prediction at this point without those advanced tools is meaningless. Okay, so don't do it in this course. All right. And so we answered exercise 2. R and R squared. There was actually a great discussion post that was posted last night about this. R is known as just the correlation coefficient. So we can get a lot of information, positive, negative, so direction of the correlation, as well as strength, weak, moderate, or strong. R squared, as we talked about, that can only give us the strength of the correlation, so weak, moderate, strong, and nothing else, okay? R squared is actually called the coefficient of determination. And really, so to get R squared, we literally square R, whatever R is, and vice versa. If we want to get R from R squared, we have to square root it. We get a plus and minus. We have to be careful with that, right? So caution with going from R squared to R. And let's see, also the other thing about R squared is I'm gonna say this slowly, and I want you to make sure to get this in your notes. R squared, how we interpret it is the percent of variation in the response variable that is explained by natural variations in the explanatory variable. Okay, so in the case of our chart here, R squared was 0.25. So let's 0.2593. Let's say that's 0.26. Okay, so I could say here 26% of the variation in variable 2 that we see is explained by natural variations in variable 1. Okay, so I mean the ideal case would be R squared is like 1, and then we would say 100% of the variation we see in variable 2 is explained by natural variations in variable 1. Okay, and what that gives rise to is a nice cause and effect relationship, but we would need to do a little bit more testing for that, but it at least allows for us to have evidence towards that cause and effect relationship. With R squares that are even, less than 0.9, we can't really say much about cause and effect, but we can at least lean in that direction when we have R squares that are pretty significant, pretty high, all right? So that's really where R and R squared differ, is in that last piece in that interpretation. So there we go. A little bit of a longer video, but I hope that going through some of this stuff makes sense, provides you some tips and tricks. Remember the INC versus EXC, and then provides a little bit more clarification on R and R squared.